When we have atoms interacting, basically we are looking at chemical reaction. So chemical reaction has to do with, this interaction has to do with atoms exchanging electrons or sharing electrons. This exchange and sharing, how does it or why does it happen, or what are the factors that influences this? We have three main things: electronegativity, ionization energy, and electron affinity. Now we're looking at electronegativity. So what is electronegativity? Well, it's a tug of war between atoms for the electron. Which electron? Which they have sharing. Electronegativity is an atom's ability to pull shared electron towards itself in a chemical bond. Now, next obvious question is, well, what are the factors that affects this electronegativity value? Well, it depends on the atoms, both atoms, nuclear charge, shielding effect, atomic radius, and electronic configuration. So basically, if you're looking at a lot of bunch of protons with less shielding, it will have higher electronegativity. Indirectly, the radius will reduce, and this also leads to higher electronegativity. And if the configuration, if you look at in terms of configuration, closer we are to a full valence shell, higher the electronegativity. Okay, so let me show you guys this. So now let's take up the most commonly used row. So we have sodium, magnesium, aluminum, silicon, so on and so forth. So in this row, which has, which satisfy all of this condition, that is, which leads to higher electronegativity? Yes, chlorine, right? It's closest to the noble gas and it has a lot of protein and less shielding. Does it make sense? Okay, so when you compare sodium and chlorine, sodium is on the extreme left and chlorine is on the extreme right. So we are looking at electronegativity of sodium is 0.93 while electronegativity of chlorine is 3.16. So if I show you guys the radius, let me show you from a different perspective. Yeah, that's your hydrogen, helium, and all of that, right? So when we look at the radius per se, let me go the other way around. The radius of hydrogen is much greater than that of helium. What I'm trying to show here is when we move from left to right, okay? Again, I've turned the periodic table over here. So what you're looking at is an upside down version or left, inverted version, lateral inversion. So basically I'm standing over here and looking at this. So when we move from right to left, technically we're moving from left to right in a periodic table. So we can see that the radius, it's reducing. Okay. So basically this, can you see that? We have sodium over here, right? And chlorine over there. Okay, over there. So what I'm trying to show is, as in when we move to the right, the size of the electron reduces. Okay. As a thumb rule, you can remember that way. Okay, so we can see that chlorine has a better value than sodium. So to conclude, higher the electronegativity value of an atom, the stronger its ability to attract shared electron in a chemical bond. And we can clearly see this in periodic table, right guys? So if you understand all of this, then it makes sense. If you've not seen what is shielding and all of that, this is not the place to understand this. A very simple concept. Please watch the first set of videos, and then the consecutive videos. Don't start in the middle. Okay, and this was your electronegativity.